Hi, my name is Myra Arroyo, and this is my final exam assignment for BUSAD 360 online. We'll get started. I recorded this once, and the first time was super, super long, so I'll just kind of zoom through this so it's not too super long and boring. But so number 1 through 6 was the Colorado data set. I didn't have troubles with this. It was actually fairly pretty easy for me. So number 1, it says calculate the change in Trump's vote from 2016 to 2020, create histogram. Colorado. So basically what I did for this one is my information. I added a whole other column, and then I just labeled it change in votes for Trump 2016 through 2020. Basically what I did, here's my equation. I did F2, which is the 2016 Trump vote percentage, minus I2, which is Trump votes percentage in 2020, and I divided that by the 2016 vote percentages, and so that's how I got this outcome. After I got that outcome, I highlighted it all. I went to insert, and then I just inserted a histogram. Here's my histogram regarding that information right here. And so that was for number 1. Number 2, it says illustrate the relationship between 2020 Trump vote percentage and household income with a scatter plot. So basically it was the same concept as the histogram. It's just this time choosing a scatter plot instead of the histogram. So I placed that one down here because I was just running out of room up there. Oh, no, that's my scatter plot for the other one. Sorry. I did put the one for number 2 down here. So basically what I did is I highlighted the row of the 2020 Trump vote percentages, and I did control and highlighted the household income. And after I had both of those columns highlighted, I just went to insert again and did a scatter plot. And here it is. As you can see, that it's kind of scattered everywhere. There's not a consistency or like really a trend. It's just kind of just everywhere. And then for number 3, it says illustrate the relationship between 2020 Trump vote percentage and bachelor degree or higher percentage with a scatter plot. So, that one is down here, just because I didn't want to jam everything up over there. So basically what I did, I just did the same. I highlighted the column that had the 2020 Trump vote percentage and the bachelor degree or higher percentage. Those two are right next to each other, so it wasn't really hard to get those highlighted. And then as you can see, this is kind of more together. You can kind of see the line going through it, which that's the next questions. But that's my scatter plot for those 2 columns. Excuse me. And then number 4 is sorry. Number 4 is what is the linear equation representing the trend line between the 2020 Trump vote percentage and the bachelor degrees. So to get my trend line, I just basically, after I had my equation, my scatter plot, I just clicked on it twice, and then let me move this over 1 sec. I went to customize, and then I went to chart and axis title. So then you scroll down. No, it wasn't the chart and axis. Sorry, excuse that. It was a series. I just clicked trend line, and so that's how my trend line appeared. I kept it polynomial to 2nd degree, and then I just used the label of equation and the R squared. So that's how I got all my information on my scatter plot. And then for number 5, it says what is the R squared value associated with trend line in problem 4. I just R squared that I got was 0.551, which I labeled that right here. Sorry, I'm kind of going fast. My first one was super long, so I don't want to make this super long either. Number 6 says use a linear equation from problem 4 to estimate 2020 Trump vote percentage and hypothetical county of bachelor degree of 35. So basically, the linear equation I got from my scatter plot is right here. And then once I plugged in 35%, I didn't type out the equation just so it wouldn't be all bunched up. But when you click on the 91.24, here you can see my equation, and I just plugged in the 0.35. I transformed it from 35% to 0.35 just because we were working with decimals. So I transformed my percentage into decimals so that it would work out a lot better. So that's how I got my answer of 91.24. Okay, and that was all for the Colorado data set. I didn't have a hard time with it. It was not too bad, pretty easy. Pair of sixes. So this section is where I kind of had more of a struggle with, just because the coin toss was really easy for me when we did it in module 6, but the dice, I couldn't get the simulations with the dice. So for the first question, I think the first 3 questions all on the dice were: use a stimulation to estimate the probability of throwing 1 or more sixes when rolling 3 dice. For number 8, it's from when throwing 2 or more sixes when rolling 3 dice. And for number 9, it says throwing 3 sixes when rolling 3 dice. So basically, I had the total roll right here. I inserted that, and for the total roll, I just added all 3 dice. And then for this one, here's my equation that I used. I kind of struggled because I couldn't get, when the simulations would run, I couldn't figure out what to put in the equations to get it to the right point. Like, for example, the first row of F says roll result 1 6. It's a loss right there. There's no sixes. And there's 1 right here. So there's actually 2, but I labeled it as 1. So this is the equation that I did the if and and statements. And then for the second one, I switched it up a little bit. I did them all equaling each other, all equaling 6. So this is the loss. And here's a single. I just labeled it as a single, but in all reality, it's like a double. So as you can see, there's 2 6s right there. There's a loss right there because there's only 1. And then this one, I think it got a little confused, or I don't know what happened there, but that was the best that I could come up with. I kept breaking my head and I could not get it. But for the row 3 was a lot easier. This was my equation that I did. The probability of rolling all 3 6s, which I think they call it a snake eye. I'm not sure if that's correct, but it's really low. It's really hard. Like, you keep scrolling and scrolling. There was one time that I had done it, one of the stimulations, and it popped up as a 1, meaning that there was one time that 3 6s rolled. So that's how I know that. That's why I stuck with that equation, because it did pop up once in one of the simulations. But yeah, other than that, it's just going to be losses, because rolling a 6 3 times is really difficult. And so that was my, I don't know why that was my pair of sixes data set, which, like I said, it was a little harder for me just because the equations is what I just struggle to put them in the right order to get what I want. So it just kind of, it frustrates me after a while. 10 through 14 was regression output. For number 10, it says write the white hat equation with the regression model. So basically, I just got in the habit of highlighting everything like we did in the modules. That was important that we need to look at. And for that, for my white hat here, I highlighted it. How I got it is off of my coefficients. So the first coefficient is the intercept. Then I added the bachelor's degree or higher. After that, I added the unemployment percentage coefficient. Then I added the urban percentage coefficient, and then I added the household income. And so to each of those, I multiplied it by what they are. So for example, the negative 1.7238 is a bachelor degree higher percentage coefficient, and I just multiplied that by x1, which x1 is the bachelor degree or higher percentage. our X2 right here is our unemployment percentage, and our X3 is our urban percentage, and our X4 is our household income, which those are basically like once you want to insert data into it, into your y hat equation, those X1, X2 are going to help you plug in your numbers so that you can figure out how to get the answer that you're wanting. And that was for my y hat. And so next question says, which independent variable is the most significant? And then I'll read the next one, which independent variable is the least insignificant? So in my opinion, I had recalled that we talked about the p-stat value. And so if it's less than 0.05, the better. So with that, I chose my most important variable as bachelor degree, just because if you look at bachelor degree, when we look at our p-stat up here, our p-value, it's the lowest. It's not, it's the lowest out of all these other ones. So, and as you can see in our scatter plot that we had done previously in Colorado, you can see that the bachelor degree actually swayed a lot of the information. So that's why I chose it to be the most important variable. Our least important variable is unemployment, just because that value, that p-value, is 0.01, which is, out of all these, the closest to the 0.05. So, I mean, if you change unemployment, it doesn't really sway the data as much as the bachelor degree. So that's basically why I chose that one as least, because that percentage was it wasn't really as important. So that's why I put it as least important variable, which is right here. And my most important variable was the bachelor's degree. Okay. And for the next two, 13 and 14 was just data I'm putting into it. So I said I estimate the Trump vote percentage for the county with household income 70%, urban percentage 50%, employment 10%, and bachelor degree 20%. So basically for number 13 and 14, basically just putting all this information right there, all that data into our y hat equation to kind of see what answer we get. So I did these right here. Question 14 is right here. I did the 20%, 10%, 50%, and the household income. And so I wouldn't have a huge equation again. If you click right here, here's my equation up here, how I solved that. And so basically I just inserted each into where x1, x2, x3, and x4, I inserted these values right here. And basically, again, like I did previously, I changed that 20%, all these percentages, I put them as decimals just because we're working with money. So that's why I got that number. And then I didn't click the percentage up here because since it's already like adjusted, once I clicked the percentage, it was a huge number that really didn't make any sense. So as you can see, with this data set right here, we got 369.82. And then for question 15, which was this data set right here, I did the same thing. I plugged them into my equation, and this is the answer I got, 121.91. You can see there's quite a difference between the two. This one's a lot higher, and this one's a lot lower. So I'm assuming the one that's higher is more votes for Trump. Yeah, because we're estimating the 2020 Trump percentage. And so that was basically all for my regression output. And 15 and 16 was the stock market stimulation, and that's kind of what I had a little harder time with. Even in the modules, it was a really stressful module for me just because I couldn't figure it out. I think the stimulation just kind of messed with me. It was fun, but it is kind of tricky sometimes. It says use the stimulation you submitted for module 7, modification part 2, copy and paste and rebuild your stimulation. So when I copied it over, my script wasn't working, so I had to recode it and everything. Basically what I did is I went to module 7, I looked into the script and copied it because my button wasn't working, and then I just came in here, went to app script, and then I just pasted in my script the code for the previous stimulation that we had in module 7 for my other one. And so will show up here. Okay, so here's where I pasted the script from the previous module 7, and then I just saved it. And so now my button works, the script runs, and that's how I fix my stimulation. And so for numbers, for the last question, I know it said, I'll let that script run. Okay, so for the last one, it said use your stimulation to estimate the probability of reaching 1.2 million retirement target, assuming 12K in initial investment and 2K in annual contribution. Explain how you got to your answer. So this was a little harder for me because I couldn't hit that one point. Like my numbers here wouldn't change. What I did was, so I added that annual contribution of 2,000. I did the plus $B, $F, just kind of so it wouldn't move down, so it'd stay right there. And I changed that my beginning balance to 12,000. And I mean, as much as I ran it, my max would not get any higher. I don't know if my equation was wrong, but my max would not get to 1.2 million. So I honestly couldn't get to that. I don't know if it's just it wasn't possible with stimulation or the stock market or what was happening, but I did not get the 1.2 million. And that concludes my final exam. Thank you for watching. Hopefully I didn't make it too super long. Bye.